Okay, and sorry I haven't posted Monday's video. Sorry about that. You can remind me. You can email me. I just have 5 classes, and so it takes a lot of time. What are we doing here? We're going back to statistics. Number 9. Oh, so those are both the new ones. So just power series in general. Maybe this one. Okay, let's talk about this one. So this is just a power series, right? What is a power series? It's a series, but now it involves x, so it's like a function, right? So we think of this as like a function of x. And so the question, the primary question is, for what values of x will this converge, and what values of x will it diverge, right? So we want it looking for an interval of x for which this thing converges, and then everywhere else would diverge. Okay, so, and we use the ratio test. Okay, so the ratio test is going to give us, quickly here, -1 to the n plus 1, 15 to the n plus 1, x to the, so when you do n plus 1, you'll get 2n plus 2, and then over 2n plus 2, because when you put n plus 1 in for n, the 2 gets multiplied by that whole thing, right? So then it ends up being 2n plus 2. Same thing here. When you put n plus 1 in for n, 2 times the quantity n plus 1 is 2n plus 2. And then we're going to have times the reciprocal, right, because we're dividing by the original. And it's all an absolute value, and we want the limit as n goes to infinity. So we want the limit of this thing as n gets really, really big. Okay, so as n gets really, really big, what will happen to this thing right here? So we're going to simplify. So -1 to the n, -1 to the n plus 1 just means -1. This is going to give us a 15 in the top, right? How many more x's do we have in the top than the bottom? 2, x squared over. All right, so 2n plus 2 factorial, we've seen this before. It contains 2n factorial, right? So what else is there in this that's not in 2n factorial?
2n plus 2 and 2n.
The first 2 factors, right? 2n plus 2. The next factor would be 2n plus 1. And then all the rest of the factors would essentially be 2n factorial, right? So I think we got everything, right? So now we're going to take the limit of this as n gets really large. So let's just talk about the numerator. As n gets really, really big, what happens to that numerator, -15x squared? It doesn't care what n is. It doesn't care what n does. There's no n involved, right? So n can be small, n could be big, n could be negative, n could be positive. And what does it equal? The same thing, -15x squared. All right, what about the denominator when n gets really, really big? Really, really big. So we've got this finite value, basically, over a number that's getting exceedingly large, heading to infinity. So the limit is 0, regardless of x. That limit is 0, regardless of x, because you have a super huge denominator and just a constant numerator. And what do we need for this thing to converge? This has to be less than 1, right? So that limit has to be less than 1. Well, we got that, right? We got it. It's always 0. The limit is always 0, which is always less than 1. So now we're asking the question, for what values of x is that limit less than 1? Any x, right? Doesn't matter what x you put in there. That limit then will be 0, which is less than 1. So this converges for all x. Doesn't make sense. Doesn't matter what x is, your limit is 0, which is less than 1, therefore it converges for all x. And now they're asking for the radius and convergence, which is like half of the interval width, half the interval. Well, but it's all x. So it's going to be, the radius will be plus infinity. And they wanted you to put it in just like this. So if you wanted the interval convergence, you would write negative infinity to infinity, and the radius of that is infinity. Questions on this one? Any questions? Okay, what else do we have? So now, yeah, go ahead.
Well, it's not really. Well, it's 18 one of them, but I forget. How would you test when you have two numbers and then you have to put one side in parentheses, one side in bracket?
Mm-hmm.
How do you test to put it back in?
Yeah, you put it back in. So you take your two endpoints. So your endpoints, if they're finite values, will make this limit equal to 1. And we said that's the inconclusive case, right?
Yeah.
So you just take that value of x and you put it back in your series. And that will give you just a series like we've been working on the last 2 weeks. No more, x will be gone because you just substituted in the value for x. So if this is like 1/4, you put 1/4 in there and you get a series. And then you test it. It's like you got the alternating series test, geometric, p-series. What else do we do?
If it's
Comparison. If it's convergent, when 1/4 is in there, then you include it. Because what are we asking? We're asking what values of x make it convergent. So you take that value of x and you put it in and you see if it converges. And if it does, you include it. And if it doesn't, you don't include it. Yeah. Other questions on power series? Okay, so let's look at these ones that you guys... Now transitioning into the new stuff. Writing of series as functions. Let's see, statistics. So, number 4. Okay, so we've got this function, and our goal is to write that function as an infinite series. And we notice that it looks like what? That function looks like what? Yeah, so a over 1 minus r. That's right. Now, in one like this, we can take the x squared out and multiply it in later, or we could just let a be x squared. Okay, but we're going to see ones where you can't do that. You have to actually take the x squared out, multiply it in later, but we'll get to that. But for this kind of simpler example, we can just say a equals x squared. And r equals? Negative 5x. So what we're doing is we're taking this function and we're going to rewrite it as a geometric series because we know geometric series kind of look like this, right? When you add up all the terms, if it's a convergent geometric series, it's a over 1 minus r, which looks like this. So we're going to create a geometric series out of this function with a as x squared, and we know our geometric series is a r to the n. Okay, and so it would be what? This particular one will be x squared times negative 5x to the n. And now they're asking for the first 5 terms of this. So this is a sum, right? So we know, remember we worked on this. Think this, or sorry, see this, think what? See that, think what? So you see this and you think what? Yeah, so when n equals 0, what do we get? Do we just get x squared, right? We get x squared times 1. And when n equals 1, we get x squared times negative 5x, right? And when n equals 2, we get x squared times 25x squared. So this is the idea of writing the sum, writing that series explicitly, right? We're writing out what it means. N equals 0, 1, 2, 3. X squared times negative 125 x cubed. And we would just need one more, okay? And we'd have the first 5. Questions on that much? So what did we just do? We just rewrote this function, x squared over 1 plus 5x, as an infinite polynomial, basically. So if we were to add up all the terms to infinity, keep going like that, it would equal that, but only for the x values for which the series converges, right? We know that it probably doesn't converge for all x. Okay, so only for the x values for which this converges, this infinite polynomial will be the same as that function right there. So now, what about convergence? So how do we find the interval of convergence? What do we have here? It's just a power series, like all the problems you did for today, the other problems, and some you did for last time. So we've seen this before. So we got to find, how do we find the interval of convergence for that? We're going to use the ratio test, right? The ratio test is what we always do on power series. Okay? Or all the ones we did. So ratio test will be that should be pretty easy. So the x squareds are going to go away, right? But we'll just do it anyway. So x squared negative 5x to the n plus 1 over x squared negative 5x to the n. And we're going to take the limit as n gets big. And it will be. So basically we're just going to have the limit of, what, negative 5x? Which means that 5x has to be between 1 and negative 1. Because that limit has to be less than 1. So that thing, that absolute value, what's inside the absolute value can be anything between negative 1 and 1, and it will make our limit less than 1. So our interval is going to be, to start, will be from negative 1/5 to 1/5. Are you following? You good? Oh, okay. Okay, now, so the question is, and this goes back to Chris?
Yeah.
All right, Chris's question. So what do we, so we got this interval, negative 5, negative 1/5, and 1/5. If you put in negative 1/5 and 1/5 into this, you're going to get the limit equals 1. And that's our unknown, right? That's the case, it's like undetermined. So we have to actually go back and find these series when x is negative 1/5 and x is 1/5 and test them using our tests. All right, so if, let's do x is negative 1/5. So we're going to put that into here. This is the series that we're trying to figure out where it converges. So when x is negative 1/5, what will we get? I'll do it in red. We're going to get, for n equals 0 to infinity, of negative 1/5 squared, which is 1/25, but I'll write it out explicitly here. And then negative 5 times negative 1/5. So we got to figure out what series do we have there. What series do we have? Well, it's going to be 1/25 times 1 to the n. So this just turns into just the series 1/25. What do we think? Convergent or divergent? See that? Think what? See that? Think what? What do you think when you see that? What's that? And what are you adding up? You're adding 1/25 over and over again. When n is 0, it's 1/25. When n is 1, it's 1/25. When n is 2, it's 1. You're just going to keep adding 1/25. It's 1/25. So, divergent or convergent? What's necessary for a series to converge? Nice to know. The sequence has to converge to 0. And then, does it necessarily converge? No, it has a chance, right? That sequence has to converge to 0. That series then possibly could converge. Well, what does the sequence converge to? 1/25. Every term is 1/25. That's a convergent sequence. It's converging to 1/25. So the series just turns out to be adding 1/25 over and over and over again. So include negative 1/5 or not? No, I'm not going to include negative 1/5. It gave us a divergent series. So now we try 1/5. Okay, let's come back here. So positive 1/5 squared, and then this will be positive 1/5. So now we're going to have what? This will still be 1/25, but then times negative 1 to the n. Okay, so now what's this? So you see this, think what? See this, think what? What is our series? Alternating, and what's alternating? Just the sign, so it's just going to be 1/25 and negative 1/25 forever. So the first one, when n equals 0, is going to be what, positive 1/25, 1/25 minus 1/25, plus 1/25, minus. Convergent or divergent? Does it hone in on a sum and get closer and closer to a sum? That's what we're asking. No, it just is 1/25 and then 0, and then it's 1/25 and then 0. As you keep adding terms, you just keep flip-flopping between 1/25 and 0. So this thing never hones in on a particular value. Which also, again, this sequence, does it go to 0? No, that sequence diverges because it keeps flip-flopping between 1/25 and negative 1/25. So if you have a divergent sequence, the series cannot converge. If the sequence must converge to 0 for the series to converge. So you're going to include neither one in this. And so your interval will be negative 1/5 to 1/5, not including either end. Questions on this example? Okay, this is hard stuff. And I feel like maybe 50 to 60% of you are with me. So make sure you're paying attention. This is hard stuff. So we got to stay on board, okay? Let's move on. Here we go. So the other one is similar. Was it this one? It's even easier. Okay, so this one's even easier. So maybe after seeing that one, this is like really simple, okay? Compared to the last one. So let's, but now we want to do some harder ones. So the first thing, we finished off with this, but there's some more to this that I want to talk about. So at the end of class, we had so we're gonna find this thing as a power series, and this is what where I was at the end of class. And we got that it was, well, we'll just do it again. Okay, so we know this, no, this is not the right one. Not that one. Is this it? I've been recording, yes. Okay, so here we go. So this one, A equals, let's just practice here. A equals, you can use X for this. R equals negative 2x squared, so we can do the sum of x times negative 2x squared to the n equals 0. So that's like the example we just did. And then, okay, so let's write out the terms. So when n equals 0, what do we get? X. Okay, when n equals when n equals 1, what do we get? We get negative 2 x squared, x cubed, okay. Okay, I got it. All right, and then when n equals 2, we get. So when we're gonna have x, and then we're gonna have 4 more x's, and then negative 2 squared. So is that 4x to the 5th? And then we're gonna have. Let's do one more. So now this is n equals 3. So it's going to be, we're going to have 6 x's, 7 x's, right? And then what's our coefficient going to be? Negative 2 cubed is negative 8. One more. 0, 1, 2, 3, 4. So we'll have 8 x's here, and one more x will be x to the 9th. And that'll be negative 2 to the 16. And on and on and on. So in this sequence, so the way we have it set up here, this is n equals 1, 0, 1, 2, 3, 4. Correct? Okay, so here's something that you will have to do for web work. Maybe eventually. If not the next web work, it'll be the next one. So I just want to introduce it now. What they'll say is they want the answer this way. So we'll do it in blue. So in blue, they'll say, find the coefficients for this if it's Cn x to the n. Okay, so what's going on here is this is doing it differently. Notice that if you do x to the n, n's going to go 0, 1, 2, and we don't have a squared term. We don't have it to the 4th term. We only have the odd exponents. Okay, so all of the even values of n are going to have Cn's of 0. Do you see that? So if we're writing that same series this way, every time n is an even number, we want this coefficient to be 0. It's because we only get odd exponents in this series. Do you see it? Okay, so we want to rewrite this. So let's write out, so basically, this is like, so this is a new n, the blue n, okay? So the blue n. So this is n equals 1. And this was going to be for n equals 3. Why? Because n is the exponent on x. Do you see it? And so for this new way of writing this, so here n equals 5, 7, 9, etc. So then my C sub n, so then in between I'm going to have the zeros, right? So so when n equals 1, I get this one, the new n. So these are lining up this way, right? Because the way they want us to express in web work, n is the power of x. So we're only going to have the odds. Okay, but that still means that n is still going to go through all its values. So it's just when the new n is even, we want this coefficient to be 0. So Cn is going to be, for all of these, it's going to be 0, 0, 0, 0, 0. Okay, then what's the coefficient when n equals 1? So Cn x to the n. So what's the coefficient when n equals 1? 1. What's the coefficient when x equals 3? Negative 2. What's the coefficient when n equals 5? Positive 4, right? And what's the coefficient when n equals 7? Negative 8. Okay, so the point is that web work will say, okay, your resulting series looks like this. Tell me the first 5 coefficients, C sub n. Tell me the first 5 coefficients, C sub n, if it's like this. If n is your exponent on x, then what would you say? So you're not going to say 1, negative 2, 4, negative 8. You're going to say 0, 1, 0, negative 2, 0, 4. Does that make sense? That's almost the best I could do. I know it's kind of weird. But to get web work right, you're going to have to know this. To get the web work problems right, you're going to have to know how to change it. So basically, can you ask a question?
Wait, why are we including them again?
Okay, because what web work wants our answer to be in the form of is x to the n, meaning that as every time n increases by 1, you increase the exponent of x by 1.
Right.
Okay, but look at our series. It's only the odd powers. It's only the odd powers. So the even powers, so if we're thinking of it as x to the n, then we have 0 x to the 0, and then we have 0 x squared, and 0 x to the 4th, and 0 x to the 6th. So that's why these are all zeros in here.
Okay.
Does that make sense? Do you
Yeah.
see it?
Yeah.
Well, so some of the questions they'll just ask for, they'll say, you're going to get this power series. Now tell me what the first 5 or 6 coefficients are if the series was written this way. And if you have something that's only the odd exponents, then every time you have an even exponent where n is an even, that would make a 0 coefficient. Because there's no x squared, there's no x to the 4th, there's no x to the 6th, there's no x to the 8th. Does it make sense? So it's kind of like we're writing it this way. 0x to the 0 plus 1x to the 1 plus 0x squared minus 2x cubed plus 0x to the 4th minus, oh, did I miss something? Did I blow this? 1x to the 1 minus 2x cubed. Oh, so minus 4x to the 5th plus 0x to the 6th. So this is the same, exact same series as this one. It just now includes a coefficient for every power of x instead of just the odds. So this is equal to this. Yeah, probably. What is it now? This is plus?
Yeah.
Thanks. One more would be minus 8x to the 7th. So this would be that list of coefficients. So that all the even powers go away, because we don't have any even powers. So that's kind of the best I can do on that. So watch the video. If it's still unclear, watch the video again. Okay? All right. Any questions? Okay. Please.
So for the first 5,
Yeah.
is it the first 5 terms including the zeros or not including the zeros?
If it's expressed this way, where the exponents of x are every n value, you need to have the zeros because you need to zero out any x that has an even exponent. You see that?
Yeah.
So there is no x squared term. There is no x to the 4th term. There is no x to the 6th. Therefore, C sub all those coefficients for even powers have to be 0 so that we don't add anything with even powers. So notice that we still get the same series that we had above. Okay. So, new example. Harder. So we have to be a little ingenious here. So we have to think about what we can do, because what's different about this one? So I have, yeah, it's squared. And what is our form for the geometric series? A over 1 minus r. So it's not a match, right? Not a match with A over 1 minus r, which is all we can do. It's got to look like that, because that's what a geometric series is. Geometric series totals up to A over 1 minus r. So it's kind of close. So what would be a similar function, or what kind of mathematical thing we could do to get it to be A over 1 minus r? Yes, sir? Yeah, but then that's a different function, right? So let's see, square root it. Okay, here's the deal. So we could square root it, and then we would find the series, and then what would we have to do the series to get h of x? All right, so now think about that. We're adding an infinite number of terms together, and we're going to square that. Does it work? Doesn't work. Okay, good idea, though. Yeah?
Could you multiply the bottom one out to where it'd be 1 minus 2x plus x squared?
Okay, so let's think about that. Another good idea. 3 over 1 minus 2x plus x squared. So now what would your r be?
2x minus x squared.
So now we would have 3 times 2x minus x squared to the n.
Yeah,
That's another nasty one, because as n keeps getting bigger and bigger, this thing just explodes, right? So every term would have a bigger and bigger explosion of a polynomial. So good idea, it doesn't work. Yeah?
You separate the 3 over 1 minus x
Okay, so again, then, all right, so now we could find out what 3 over 1 minus x was. And then what would we need to do? Then we need to square that. And we've got an infinite number of terms times an infinite number of terms. All good ideas. So we got to, yeah.
Could you multiply the top and bottom by 1 over 1 minus x? So like 3 over 1 minus x all over 1 minus x. And then like factor out the 3 over 1 minus x.
That gets you back to where you started. Okay, so think calculus. Think calculus. We want to use calculus to do this. All right, if we did the derivative, what would we get? 3 over 1 minus x cubed. Does that help? No, we need to go what? Go the other way, right? If we go the other way, what do we get? So if we do the integral of what do we get when we do that integral? We should all know what we get. Now it's squared. It's squared. Okay. So it's just power rule. Just undo it. So basically we have the power -2. So it's going to become, sorry, dx, right? dx. So power -2, if we do antiderivative, becomes power, nope, antiderivative, -1. Okay, now it looks like what we want, right? And we have the 3. So we got to check, is the derivative of that? Do we have a sign to take care of? So let's try it. So 3 times 1 minus x, this is what we got. We're going to take the derivative, get -3, 1 minus x to the 2 times chain rule, -1 by the chain rule, which makes +3. Is it a match? Perfect. So we got it. Now what about that? Can we do it? So here's the deal. We're gonna find the series for that, and what will we do to the series to that to get the series for h? Take the derivative of it. See? So we can get that series because it's a over 1 minus r, and if we take the derivative of it, it will be the h function. Pretty cool. Why do I have -3 over 1 minus x here? In my notes I have -3 over 1 minus x. That's wrong, right?
I think you forgot to do the opposite of the chain rule, because since it's 1 minus x,
Mhm.
if you were taking the derivative of that, you'd have to also multiply by -1, because the end exponents it would equal out.
Right.
I think you did it up here correctly, but I don't think you did it in your notes.
Yeah, I think this is right. I think this is right. You're saying this is right, right?
Yeah.
Yeah, I think my notes are wrong. Which is fine. I'm just glad we caught it. So let's check one more time. 3 times -1 to the -1, -3 to -2 times yeah, this is right. So it's this. It's not -3. Okay, we're good. So here we go. What is A and what is R?
A is 3, R is x.
So here's what we're going to do. When we do these, we're gonna write out this series 3 ways, and this is going to help us. We're going to write it out as the function first. So the function, what is the function? 3 over 1 minus x. And then we're going to write it out in sum notation. So in sum notation, what will it be? N equals 0 to infinity of 3 times x to the n. And we're going to write out what it means. I'll show you why we're going to do this in a second. So we see that, we think what? First term, 3. Second term. Next term. Easy, right? So all 3, we're going to write it out all 3 ways. And this is going to serve as a check for us. Why? Because what's our next step? Is this the function h of x? No. How are we going to get h of x? We take the derivative, right? We just found the antiderivative. And so now we're going to take the derivative of this, and that will be h of x. And we're going to take the derivative in all 3 forms and compare the forms. And if the forms equal each other, then we know we did it right? So we know we've already taken the derivative of this. So h of x equals, we've satisfied that is our h of x function. Okay, so now how do we, so we know this is every term, so we can just apply our derivative rules to that. Okay, so 3x to the n. What's the derivative of that? 3n times x to the n minus 1. Okay, and then now we're going to do it term by term, derivative, right? So derivative, 0 plus 3 plus 6x plus. So now the question is index, okay? So n starts at what? What do we want? So when you do this thing with taking derivatives and integrals, things get screwy with the indices. That's why we're writing out the terms too. So we can just try something, try an index, try starting at 0, try starting at 1, and see if you get these terms. We know this is right, so we just need to make the index work so that we get these terms. So try n equals 0. Does n equals 0 give me these terms right here? Well, so n equals 0 would give me what? 0. N equals 1 would give me 3. It works. Look at me like it works. N equals 2 would give me, it works. See this? Okay, but here's the deal. In web work, they're going to want it as x to the n. They're going to want this series for h of x. So they're saying find h of x. Find it in this form. C sub n x to the n starting from 0.
Did they tell you to do that? Or should
Yeah.
you do it for every problem?
Just read carefully. The instructions should be clear. But most of them, a lot of the problems will be like this. They'll like find h of x in this form and write out the first 5 coefficients or something like that. It'd be different on different problems. Let's see here, what can I do? Question?
So then the coefficient would be like 3n to the x times x to the n.
We're getting there, so just hold tight for a sec. So we want to write this now as n equals 0, where it's going to be x to the n. And c sub n. Okay, so basically, when n equals 0, then what term do we need to get when n equals 0? We need to get, so when n equals 1, we need to get this term, right? So when n equals 0, we need to get this term. So what does that make? Let's see, how can I explain this? I'll explain this well. Okay. So now, when n equals 0, we need to get a 3 there. And when n equals 1, we need to get a 6. So what is our c sub n formula? So before it was 3n. But now when n equals 0, we need to get 3. And when n equals 1, we need to get 6. So what happens to the n in our new formula? Yeah, it's n plus 1. So it's 3 n plus 1. Why? Because when n equals, let's try n equals 1. When n equals 1, I need to have the linear term. So I need 3 times what is going to give me 6? Well, 2. So I need n plus 1. So all the n's in this coefficient right here, this n, they're all 1 greater now that I have n equals 0 to be this one, n equals 1 to be this one, n equals 2 to be this one. So that is our series for h of x. Okay, and then you can find the interval convergence it's a power series. So we use the ratio test, find the interval of convergence. Jonathan.
I'm confused because I thought you said the series above that worked.
This works, but in WebWork they may say you're gonna find h sub x in this form. They're gonna say find it like this. Cn x to the n, where n starts at 0. That means your n has to match your degree of the term, and it doesn't here. So here, our n is always 1. Our degree is always 1 less than n. But here, your degree of your term has to be n equals 0. Does it make sense? Yeah.
What was the purpose of finding the index where n equals 1?
To figure out how this changed. So what happened was all the n's got increased by 1 when we did this. So so before what? So this was n equals 0. This is before. N equals 1, n equals 2, n equals 3. And now it's n equals 0, n equals 1, n equals 2. So it's shifting the index, basically, shifting the index. So whereas before, when we plugged in n, we got 0. Now when we plug in n for 0, we need to get this term. And that means when n equals 0, we need to get this 3. So 0 plus 1 times 3 is 3. And then when n is 1, we need to get this coefficient 6. Why? Because it's a linear term, x to the 1. So 1 plus 1 is 2 times 3 is 6. So you find the interval of convergence. That's an easy one. That says find interval of convergence. Other questions? Okay, it's time for you to try one. Here you go. Try this. And I'll take attendance, and we'll do this first. Did they drop? They weren't going to get up. Lay. Lay. Nathan. Neil. Rudy. Howard. Ming. Alceo. Try to just glance at your score. Try to stay focused on that. Everyone's got their equipment back?
So if you do x times,
This dude?
Probably a good idea.
Just make sure we're getting off on the right foot. What are we going to do? Sorry. So So this is the example where we're going to get rid of the x, and then when we're all said and done, we're going to multiply it back in. Sorry. So we're going to do this. So some other function. So we're going to do x times g of x is going to equal x times 1 over and this way, no, so we're going to work on g of x, and then once we get f of x, then we'll multiply that. Once we get the power series for g, then we'll just multiply it by x, and that'll be the power series for f. Do you see it? So you have a fighting chance now with g. Sorry. Yeah, well, that's the meaning of a fighting chance. It's slightly possible, right? So you can work on g, and then once we get a power series for g, what we know is that f is just x times g. Sorry. So now you're work on g of x. So what are we going to do with g to get started? We need it to be 1 over 2x plus 1 to the 1. So it's just like the last example. So we're going to do antiderivative of now we've got slightly harder antiderivative. And we've got to make sure we get right, or else we'll do a lot of work that's wrong. So we got to make sure this antiderivative is right. So we want, what's our goal? Our goal is over 2x plus 1 to the first, right? So then the question is, what do we need? So you can make your first attempt 2x plus 1 to the minus 1, and then see what you need. The derivative will be times. So what do we need so that that is exactly like that? Negative 1/2. So that becomes our A. So then A is negative 1/2, and R is, what's R? Not 2x. It's negative 2x. So our A is negative 1/2, and our R is negative 2x.
Is it okay if you simplify that more? Or we just
What do you want? How do you want to simplify it?
want it to be negative 1 over 4x?
No, because then it'd be 4x plus 2, and it needs to be 1, right? Because the formula is A over 1 minus R. You've got to have a 1. So this is a really important question. He wanted to move that, just say negative 1 over and then multiply the bottom by 2. But what's the formula for our geometric series? A over, it's got to be a 1. It has to be a 1. It can't be anything else. It must be a 1. So by doing that, then it doesn't work. So just keep A as negative 1/2 and R as negative 2x. So here's where you're gonna write that function three ways, and then what are you gonna do to it to get the function g? Take the derivative and write the derivative three ways. Okay? So you're gonna write that function three ways, and we know its derivative is our function g. You're gonna write g all three ways. Yeah.
Are you sure that a is -1/2?
I'm pretty sure. 99% sure. Because if I do so we started with, so we'll just do it. So -1, so -1/2 times 1 plus 2x to the minus 1. We're taking the derivative, and we just need to get exactly that, right? So -1 times -1/2 is +1/2. 1 plus 2x to the minus 2. Chain rule times 2. So 2 times 1/2 goes away, and we got it. You see it?
Yeah.
This is just power rule basically. It's kind of like undoing the chain. So it's just gonna, we know that when we do the antiderivative, it'll be power -1. So then I just,
Okay.
yeah, you can do U sub if you want. I just think it takes longer. Yeah, if U sub will work. It just takes longer. I tried to give you that tool at the beginning of the semester. Okay, so you're writing this thing out three ways, and then you're doing the derivative all three ways. So you have something to compare.
Should we multiply x stack?
When we're at the very end.
Very end?
Well, okay, so this is going to bring into that the thing with x to the end. So, yeah, so after we're sure about what g of x is, that's when we multiply x.
Okay.
So, yeah,
So -1/2.
So it would just be n to the x. So that
So first we're going to write it as sum. The sum's going to be -1/2. Starting at okay, and now we're going to write out what it means. So three ways. We write out this antiderivative three ways, then we'll take the derivative all three ways. Make sure it all adds up, or all coincides. Okay, so see this, think what? -1/2, n equals 1. X, n equals 2. -2x squared, I do believe. N equals 3.
4x cubed.
Positive 4x cubed. Let's do one more. N equals 4. X to the 4th. Minus 8 x to the 4th. And we know they keep going. I just don't have room for the dots. So I'll just, here are the dots. Okay? So that is G. No, that's not G. That's the antiderivative of G. That's this thing. And to get G, we're going to take the derivative. We've already checked it a couple times. We know what's the derivative. 1 over. Okay? We're going to take the derivative of this. Okay, so here I'm going to give you something to make it easier. When you take the derivative of a power series like this, you can just switch it and start at n equals 1. Okay? Start at n equals 1. I'll show you why it works. Okay? So when you take the derivative, if you're starting n equals 0, now you can start at n equals 1. And what will it be? -1/2 n times. Gotta know how to do this. To the. Are we done? Chain rule times -2. Chain rule. Okay, it does, but it doesn't cancel if you don't put it there. Okay? It doesn't cancel if you don't have it. So by the chain rule, you need the -2. You need the -2 by the chain rule. So we'll simplify that in a second. Now the term by term. What do we got? Derivative. -1/2. Derivative. 0. Derivative. 1. Derivative. Minus 4x. Derivative. 12x squared. Derivative. Someone had a question over here. Yeah.
Why'd you put the n after the negative 1? I know that's the formula for the other one, but what formula?
It's the power rule. We're taking the derivative. It's something to the n. It's power rule. Something to the n. So it's going to be n times that thing to the n minus 1, and then by the chain rule times negative 2. It's just derivative. Doing derivative, right? So now let's make sure, by starting at n equals 1, did it work? Did it work? So when n equals 1, what do we get? Oh, so yes, we can cancel. So let's cancel. So bye-bye. That's nice. Okay, so when n equals 1, so let's make sure, by starting at n equals 1, do we get the same series? So when n equals 1, we get 1. There it is. So here's n equals... n equals 1 is right here. If n equals 2, what do I get? 2 times negative 2x to the 1, which is negative 4x. N equals 2 gives me that term. It's working, right? N equals 3. 3 times negative 2x squared. Is it positive 12x squared? It is. 3 times, it's going to be x squared, and this is going to be negative 2 squared. It's 4 times 3 is 12. And then one more try. N equals 4. We're going to have x cubed, that's right. And then we're going to have 2 to the 4th times 3. Try that again. Is that right? 2 to the 3rd times 3. 4. 2 to the 3rd times 4. So yeah, so it's going to be the 3rd power of negative 2. It's negative 8 times 4, negative 32. N equals 4. Okay, now. Now we want this thing. Okay, so what do we want? We want F. So this is G, right? So we just found the power series for G. And what's the power series for F? Yeah.
I was wondering, like, in comparison to the last problem, why does this one have n?
Because I was telling you, I just told you that to make it easier than the explanation that I gave in the last problem, when you take the derivative, just start at n equals 1, and it will work.
Okay.
And then when you shift the index, you shift it back. You're going to shift it back to 0, and then all these will add by 1.
Oh.
So it's just a rule you can follow that works, rather than trying to explain it term by term, like I did in the last example. When you take the derivative, if you're starting at n equals 0, you can start at n equals 1, and then if you needed to shift the index back, you could start at 0, and then all the n's get added to 1. So if you subtract 1 here and add 1 to all the n's, it's the same series.
But you wouldn't need to shift the index back unless it asks you.
Right, unless you need x to the n. You need it to be in the form x to the n. Yeah, if you need the series to be in the form x to the n, but that's going to happen automatically when we multiply by x here, so we don't have to shift it here. Yeah.
Why did we write 0 in the first place?
What's that? The derivative of negative 1/2. We're taking the derivative of the terms. So it's being. I think you got it. Does that make sense? Yeah, I'm just doing so. Well, like I said, we're gonna write out the antiderivative of g, and then we're gonna in all 3 ways, and then we're gonna do the derivative of g in all 3 ways. Sorry, derivative of that in all 3 ways that gives us g. So this is our g function. This is our g function. Okay. So this isn't hard, right? So we're doing okay? All right. All right, so now, what do we know? This is g. We want f. What is f? F is times x. So we're just going to multiply every times x. Times x. And this whole thing. Times x. Okay, this line was g, and now we're getting f. So what is f? So it's x over 2x plus 1 squared. We got one more to do, so we got to get there. Okay, and now what's this? Just multiply x in here. So n equals 1 to infinity of n. So it'd be negative 2 to the n minus 1, but now we have another x, so it'd be x to the n. So I split those out, because we're going to multiply by x. So I'm going to do negative 2 to the n minus 1, and then x to the n minus 1, but it's times x. So it's going to be x to the n. And that's going to be just times x. So the first term should be x, and then minus 4x squared, plus 12x cubed, minus 32x to the fourth. So does that equal this? So this is like our trusted thing right here. This is the easiest thing over here. So we check this against what we got here to make sure that this is right, because this is going to be the answer. So when n is 1, what do we get? We get 1, we get x to the 1, and we get 0. Got it, x. When n is 2, what do we get? We get 2 times negative 2 is negative 4x squared. There it is, negative 4x squared. When n equals 3, we're going to have 3 times 4x cubed. It's working. It's working. Got it. So remember, this line was the g function, and then we multiplied it by x to get the f function at the very end, right? So we took the x out at the beginning, we did the whole problem related to g, and then we multiplied the x back in at the very end. And this is our f. Okay, now notice on this one. It would be exactly the same if we just let n start at 0, right? Because if we let n start at 0, then what would the first term be? 0. So this would be exactly the same as now just writing n equals 0 for the exact same series. Because then you'd have the first term 0, and then n would be 1, and you'd get all these terms. Adding 0 to it doesn't change it. So for this particular one, we could start at n equals 1 or 0. So we could just change that to a 0, and it's the same thing. These are the little things you have to, the nuances that you have to be able to do on some of these problems. Okay, we should at least start one more. Questions? Any last chance? Okay. So what's the trick here? We got x squared times natural log of 1 minus x squared. What are we going to do first? So what do we need? We need something, we need a function related to this one that's like this. A over 1 minus r. Take the x squared away. So x squared, call it, what do you want to call it? K of x, right? So x squared times k of x equals j of x, where k of x is what? Oh, we didn't do it. We never did it. But you're just going to do a ratio test. It's a power series. Do ratio test. K of x is? Okay, so got rid of the x squared. And we need this. We need something that looks like this. A over 1 minus r. It's going to hit someone over the head like a ton of bricks. What are we going to do to get something that looks like this? A over 1 minus r. Take the derivative. And then when we get the power series for that, what are we going to do to get k of x? Antiderivative. Antiderivative, right? So we're going to take the derivative of k of x. And what do we got? 1 over 1 minus x squared times negative chain rule, negative 2x. So a is negative 2x, r is positive x squared. right? A is negative 2x, r is positive x squared. So we're going to find that one, and how are we going to get kx? Take the antiderivative, and then how are we going to get jx? Multiply by x squared. So let's write it out. So here we go. So this first one is, we're doing minus 2x over 1 minus x squared first. Write it as a geometric series, power series, I mean. It's going to be negative 2x times x squared to the, let's write out some terms. N equals 0, we're going to get, no, negative 2x. N equals 1, 2x cubed. N equals 2, and then n equals 3. Okay, I think that's enough. All right, and then, so this is that one. And how are we going to get, so what's k of x then? Antiderivative of this. And so we already know what it is. It's ln. We already know that because we took the derivative to get that. All right, so antiderivative. Here we go. So to get the antiderivative, we need to combine this stuff. So we have x to the something. So this is minus 2 x to the what? 2n plus 1. That's what that is. Now we can do the antiderivative, which will be x to the 2n plus 2. Raise power, right? Antiderivative, raise power. And then we're going to take what? You need 1 over that, right? We need 1 over that. So it'll be negative 2 over 2n plus 2. Yeah. But let's just, so we know what it is, we're going to leave it this way. Did you catch it? Antiderivative of x to the 2n plus 1 is 1 over 2n plus 2 times x to the 2n plus 2. Power rule for antiderivative. And I held on to the negative 2. Okay? Antiderivative. Antiderivative of negative 2x. Antiderivative. Right, negative x squared. Antiderivative. Negative 1/2 x to the 4th. Antiderivative. Negative 1/3 x to the 6th. Are you following? Negative 1/4 x to the 8th. So this is kx. Now we got to get the index right.
And that's starting with n equals 0.
So is that right? Does n equals 0 give me that? Negative 1 times x squared. Exactly. So this is right here. Yep. So n equals, this is 0, 1, 2, 3. Okay, so we got k of x. And what is j of x? So we're going to multiply now by times x squared times x squared. And this whole thing times x squared. So we know we'll have x squared ln of x to the 1 minus x. That was our original function we were going for. So what happens when we multiply that thing by x squared? Negative 2 over 2n plus 2 times x to the plus 4 equals times x squared, negative x to the 4th, minus 1/2 x to the 6th, minus 1/3 x to the 8th. etc. Okay, and so we just want to check, first of all, we want to check to make sure that when we do n equals 0, 1, 2, 3, we get these terms. The reason that we're doing it, the reason that we do it on these individual terms like this is because we trust that. We trust doing things one term at a time, and so then once we get this, we can check. Check, make sure that that thing gives us those terms, right? Antiderivative times x squared. We trust that the most. This is where we're dicey, right? This is where we're dicey, so this stuff serves as a check for that. Now, here's another example of what if WebWorks says, give me the coefficients where this is something times x to the n. It's that thing we did earlier in class. So that you have to be on the lookout for that. You have to figure out what coefficient you're going to need and what's going to be 0. Because what we only get, like we start at 4 and then we only have the evens. So every odd exponent, so here. So if they want it as x to the n, then what? When n equals 1, coefficient 0. When n equals 2, coefficient 0. When n equals 3, coefficient 0. Then when n equals 4, coefficient is negative 1. When n equals 5, coefficient is 0. Then when n equals 6, coefficient, etc. Does it make sense?
Find a lot of zeros.
Have fun.